All right, everyone. So this week we're focusing on areas of regular polygons. So far we've done mostly just quadrilaterals and triangles. So now we're moving on to shapes that have more sides. So our learning target is that we can use segments of regular polygons to find areas and missing angles. So for a quick do now, take a minute to find the measures of the missing angles here. And this is a little bit of review. So if you need to pause, go back through your notes from before and try this out. I'm going to go ahead and go through these just to kind of get the review in there. If you need to pause and want a little bit more time, that's totally fine. Number one, remember with triangles, we're always subtracting from 180. So just do 180 minus 29 and then minus, don't forget to subtract this 90-degree angle here. And that leaves us with 61 degrees for x right there. For number two, notice that this is actually a square, right? We have four congruent sides. So if this is a right angle here, then x over here is also going to be a right angle, right? So x is going to be 90. And then y and z, because this is an isosceles right triangle, are just going to be 180 minus 90 and then split up, right, with whatever's left over there. So we know that would be 45 degrees. Number three is a hexagon, so it has six sides, and they're all congruent. So that means that each of these little sort of triangle segments is going to be congruent, right? Because we have all these sides that are the same. And so for x, we're basically just going to take 360 and split it up into six parts. So that gives us 60 degrees for sort of each of these interior angles here. If I try to find y and z, think about it, right? If I do 180 and I subtract 60 from it to get rid of that x, I'm left with 120 degrees to kind of split up between those two base angles in my triangle, which leaves me with 60 degrees. And I know that this is an isosceles triangle, right? Because we're going out from the center there. So all these lengths are going to be congruent. So some quick vocabulary, a little bit of this is going to be a review, and then a lot of it's going to be really important new stuff to use for our formulas today. So this is a review definition, a regular polygon. Remember our definition is that they are both equiangular, meaning they have equal angles, and they're equilateral, right? So all the sides are the same. So that square and that hexagon we just saw in our do now are regular polygons. Okay, so here's just a picture of them again. So just as a reminder, the angles are all equal and the sides are all equal, right? Same thing over here, all equal angles, all equal sides. So this is kind of a new, not new for circles, but new for polygons. The radius of a regular polygon is the distance from the center to one of the vertex points. So if I have my regular hexagon here, my center is just going to be that point kind of right in the middle. And then the vertex is obviously right out here. So the radius basically goes from the center to the farthest away point on the shape that it can, right? We're not going just straight into the middle, we're going all the way out to a corner. The opossum, this is a new word that I'm guessing most of you probably haven't heard before for this topic. The opossum is kind of like the height of a polygon almost, but it's the perpendicular distance from the center to the middle of a side. So it's sort of like the height of our parallelograms and our triangles, but it only goes to the center and then is perpendicular to one of the sides. So it's a little bit different than the radius, right? It's a little bit shorter than radius. So example one, finding angle measures, and this is important, right, that we have kind of our radii and our apothem words here. But the figure at the right is a regular pentagon, so five sides. It has all these blue radii and then this red apothem drawn right here with that 90-degree angle. What's the measure of each of the numbered angles? So pretty close to what we did on our do now. But to find angle one, which is in this little triangular section here, we're just going to take 360, right? Because we know there's 360 all the way around and split it into five parts, right? So 1, 2, 3, 4, 5 for each of the central angles, and that'll give me 72 degrees. Then to find two is kind of just like angle one, but split in half. So I just took 72 degrees and split it in half. So I get a 36-degree angle for number two there. And then for number three, I personally looked at this kind of little triangle here, just because I didn't want to, I do know that because the radii are congruent, I could use an isosceles triangle, but I'm a little bit lazier than that. So I just went with this angle two here, which is 36, and this 90-degree angle here, and just subtracted from 180 and got 54 for angle three. If you want to do that isosceles triangle math, that's totally fine. You would just want to start with 72 up here and subtract 72 from 180 and then split it in half, which is literally going to give you the exact same answer, just one extra math step. All right, so in example 2, we're going to start finding areas of regular polygons, and hang tight with me here because I'm going to take a minute or two to just sort of give you an explanation of the formula that I'll give you on the next slide. And the formula is actually quite simple, but the reasoning I think is really important, the reasoning behind it. So here we're trying to find the area of a regular decagon. And remember that a decagon has 10 sides in it. And hang tight with me here, you guys, because I am going to be using my finger to draw because I don't have my stylus, and it may be quite bad. But just be patient with me. So I'm going to draw in all of the radii, right? So from the center to the vertex here. Oh, I'm not doing too bad yet. Okay. So there's all of my radii. Um, so if you can see, I'm actually kind of looking at a bunch of little triangles in here, right? So I've got all of these different triangles. I know that since this is a regular decagon, that all of my side lengths are the same, right? So if this side over here is 8, then this side right here is 8. And so I've got all these sides of 8, and then the apothem going all the way around is going to be the same, right? So I have this 12.3-inch apothem. So I'm basically looking at a triangle here that has a width of 8 and an apothem of 12.3. Well, can you imagine if I basically like cut sort of right in the middle here and just started to almost unroll like an orange slice, this little decagon that I have here, so that I basically just like had all of these triangles, right? And obviously I can't keep going in that direction. I can draw one more over here. But I would have 10 of these triangles, right? Um, and so what I'd have to do is do base times height, or sorry, 1/2 base times height to find the area of this triangle here, right? Find the area of that triangle, find the area of this triangle, find the area of this triangle, and there's 10 of them, so I multiply them by 10 and blah, 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 right? So it's going to take kind of a while to do that. So here's kind of the quick version or the quick formula for areas of any regular polygon is we're going to do A equals 1/2 A times P. So important things to note is that lowercase a stands for the apothem, and then P stands for the perimeter. So we're basically going to like take all the bases of the triangle, if you will, each triangle, um, and just multiply it, right? Find what the whole total perimeter is. And we just do that. So this is basically like a area of a triangle formula, but we're using a perimeter instead of the base, right? But apothem's kind of like the height, perimeter is kind of like the base if we unroll our shape like an orange slice. Okay, so if we go back to the exact same problem we were just on, finding the area of the regular decagon, we know the apothem right off the bat. And we know that the perimeter, we're only given a side length of 8, right? But the perimeter has to be 8 times 10 because we know a decagon has 10 sides, right? So I just took my side length, multiplied it by how many sides there are, and that gives me a perimeter of 80 inches all the way around, right? So if I was going to like unroll my orange slice and split it up into all those triangles, it's like it would have this long base of 80 inches. From there, once I know the apothem and perimeter, I just go 1/2 apothem, perimeter, multiply all that stuff, and then I get 492 inches squared, right? So once you know these two numbers, rather than having to kind of think through like where are the triangles, what's the height, what's the base, how many triangles do I have, if you have these two numbers, you can just plug them into the formula and it's super fast. Okay, so here's our third example. Find the area of this regular octagon. So we know an octagon has 8 sides in it, just as a little reminder. And you can always, I mean, look up on the Google and find, if you're kind of wondering like pentagon, hexagon, octagon, how many sides are in each of those, just Google it. So this one has an apothem of 20 inches, and then it has a side length of 12.8 inches. So I just kind of sketched out a little octagon over here. And it tells me it's regular, so I'm not going to bother drawing in all the, congruent sides and stuff. So we know the apothem. We don't yet know the perimeter, but since we know that there are 8 sides, we can pretty quickly find it. So I just took my my side length, which is 12.8. That little S, by the way, means side length, if you see that on your homework. And I just multiplied it by 8 sides, and that gives me a perimeter of 102.4 inches. Okay, my apothem we already knew was 20 inches, and now I just have to plug it into my formula, 1/2 apothem times perimeter. So 1/2, 20 times 102.4. And then when I simplify that, half of 20 is 10, and then just multiply it, I get 1,024 inches squared. And that's all for today. So your assignment is page 631. Make sure that you guys are kind of showing all your work and showing all of your thinking, plug your numbers into your formula, and make sure that I'm able to follow along when I look at your assignment. Have a great day.